America is building machines so powerful, the whole world is watching in disbelief. Deep inside secret labs and vast deserts, scientists are harnessing energy hotter than the sun, energy that could power entire continents without burning a single fossil fuel. This isn't just about electricity. It's about who controls the future of energy, the climate, and the economy. Nations are already worried. The world is about to change, and only a few will understand how fast. Do you want to see the inventions that are shocking the globe and redefining power itself? Comment your thoughts, hit like, subscribe, and stay with me. Let's see the 7 most unbelievable fusion technologies that are shocking the world. The National Ignition Facility in California is not just a laboratory, it is a gateway to a power unlike anything humanity has ever held. Inside its stadium-sized chamber, 192 lasers fire in absolute precision, converging on a tiny capsule of hydrogen fuel no bigger than a peppercorn. In that split second, temperatures and pressures explode to levels found only at the center of the sun, and for the first time ever, fusion energy produces more power than was used to ignite it. This milestone is not just a scientific achievement. It is a statement: humans can now touch the very forces that light the stars. The implications are staggering: clean, limitless energy with zero carbon emissions, enough to power entire cities without burning a single fossil fuel. Yes, the technology is still complex, expensive, and far from commercial use, but the proof is undeniable: fusion works. It opens the door to a world where energy scarcity is a thing of the past, where climate crises can be tackled, and where nations can rise with new power and independence. And yet, even as the lasers fire and the plasma roars, the next breakthroughs promise to be faster, smaller, and even more transformative. The Spark tokamak, developed by MIT and Commonwealth Fusion Systems, represents America's boldest push toward commercial fusion energy yet. Unlike laser-based facilities, Spark uses extremely powerful high-temperature superconducting magnets to contain superheated plasma in a perfect magnetic ring, reaching temperatures hotter than the sun's core. The design is compact, elegant, and remarkably fast to deploy compared to massive, decade-long national projects. Its promise is revolutionary: small fusion plants that could fit inside cities, ports, or industrial complexes, delivering clean, on-demand energy wherever it's needed. Imagine entire coal plants becoming obsolete, grids stabilized effortlessly, and the geopolitical balance shifting as nations gain energy independence. The ripple effect is staggering: lower emissions, cheaper energy, and a world less dependent on fossil fuels. Spark isn't just a machine, it's a symbol of what's possible when science, ambition, and engineering collide. And if its predictions hold, its larger successor, ARC, could power millions of homes sustainably. America's vision doesn't stop here. Spark is a stepping stone toward a future where fusion is no longer a dream, but an everyday source of limitless, clean energy for the world. Zap Energy's FUZ-EQ fusion reactor is a machine that defies everything we thought we knew about nuclear power. Unlike massive laser facilities or sprawling tokamaks, it doesn't rely on giant magnets, intricate coils, or billion-dollar chambers. Instead, it harnesses a sheared flow Z-pinch, a beautifully simple method that compresses plasma using only electric current. At first glance, it looks almost too small to matter, but inside that sleek tube, plasma naturally stabilizes, creating the extreme conditions needed for fusion, without enormous infrastructure. The implications are staggering. Fusion power could suddenly become cheap, fast, and deployable anywhere. Neighborhoods, factories, or even remote towns could run entirely on clean, limitless energy. No greenhouse gases, no radiation risk, no massive shutdown procedures. This is the democratization of energy power that is flexible, safe, and scalable. Zap Energy proves that fusion doesn't have to be monumental to be world-changing. And while FUSEQ pushes the limits of innovation, America is already building the next generation of reactors machines, designed to transform not just energy, but the future of civilization itself. TerraPower's Natrium reactor, backed by Bill Gates, is not just another nuclear plant, it's a glimpse into the future of energy. While it isn't a fusion reactor, its role is critical, bridging the gap between today's fossil fuel grids and the limitless potential of fusion. Natrium uses a sodium-cooled fast reactor, a design that is both efficient and inherently safe, producing carbon-free energy with remarkable stability. But what truly sets it apart is its thermal battery, a molten salt storage system that acts like a giant, glowing power bank. During periods of high electricity demand, this stored heat is released to generate power instantly, solving one of the biggest challenges in renewable energy: reliability. Wind and solar can be unpredictable, but with natrium energy flows steadily, like a river that never stops. It allows America to maintain grid stability, reduce carbon emissions, and prepare for a future dominated by clean, abundant power. Natrium is more than a machine, it's a symbol of innovation, a bridge from the energy of yesterday to the fusion-powered world of tomorrow, and a testament to what vision, technology, and ambition can achieve. Kairos Power's Hermes reactor represents a bold leap in American nuclear innovation, designed to make clean energy both accessible and practical. Unlike traditional reactors that rely on heavy water or pressurized gas, Hermes uses fluoride molten salt, a stable, low-pressure medium that carries heat efficiently and safely, reducing the risk of accidents while maximizing performance. Its compact, factory-built design allows for faster construction, lower costs, and scalable deployment, transforming nuclear power from an elite, massive infrastructure project into a versatile energy solution that can reach even remote or underserved regions. Hermes is not just a reactor, it is a stabilizer for the grid, supporting renewables by filling the gaps when solar and wind falter, ensuring consistent, carbon-free electricity at every hour of the day. Economically, it reshapes energy production, offering cheaper construction, safer operation, and rapid scalability that traditional power plants cannot match. This is America's strategy to outpace global competitors, not through sheer size, but through innovation, speed, and adaptability. Hermes proves that the future of nuclear power can be safe, smart, and sustainable. And yet, even as Hermes paves the way, the next generation of reactors promises to go even further, redefining what energy can do for humanity. The Oklo compact fast reactor may look small from the outside, more like a shipping container or a remote cabin, but inside it is a marvel of engineering. Fast neutrons race through its carefully designed core, sustaining a stable, long-lasting reaction capable of running for decades, without the need for refueling. There are no massive cooling towers, no complex shutdown cycles, no constant monitoring. It is nuclear energy distilled to its simplest, most reliable form. Oklo's vision is revolutionary: deploy these microreactors in mining sites, Arctic outposts, military bases, or remote communities, delivering consistent, carbon-free power where diesel generators once ruled. The benefits are staggering: zero emissions, minimal waste, and near-zero operational complexity. But the impact goes far beyond electricity. Whoever controls a fleet of these small stable reactors gains influence over remote industries, critical infrastructure, and even military logistics. America is positioning itself at the forefront of this energy revolution, preparing for a future where power is portable, dependable, and globally strategic. Oklo proves that nuclear technology doesn't need to be massive or expensive to be transformative. It just needs to be smart, compact, and relentlessly innovative. Petra Nova in Texas is more than a power plant, it's one of the world's most ambitious carbon capture projects, quietly reshaping how America approaches energy and climate. Instead of allowing millions of tons of CO2 to escape into the atmosphere, Petra Nova uses advanced chemical solvents to pull carbon directly from the exhaust of a coal-fired plant. Once captured, this CO2 can be stored deep underground, or repurposed for industrial uses, turning what was once waste into a resource. While it isn't fusion, Petra Nova buys humanity precious time, reducing emissions today as next-generation reactors and fusion technologies prepare to take over. It transforms aging power plants into cleaner, smarter, and more responsible energy sources, creating a transitional bridge to a carbon-free future. The project demonstrates that innovation doesn't always require reinvention. Sometimes it's about rethinking existing infrastructure and making it work smarter. For the US, Petra Nova is both a strategic and environmental tool, proving that progress can be immediate and measurable, not just theoretical. It's a stepping stone, a shield, and a promise. America is preparing for a world powered by innovation, not emissions. The world is changing faster than anyone expected. America is writing the future of energy. These aren't just machines, they're stepping stones to a cleaner, safer, and more independent world. Which of these technologies shocked you the most? Tell us in the comments. Your comments is very matters for me. And if you enjoyed this journey of the future, hit like, subscribe, and stay connected.